Hi everyone, welcome to Engineering Takeoff. In this video, we are understanding types of function. For better understanding, please watch our previous video. Link will be in the description. Without any further delay, let's understand classifications of function. Type of function has been classified into two types. One is based on mapping, another is based on degree. Based on mapping tells how elements in domain and range is been mapped. Based on degree tells degree of the function. Under based on mapping, we have one-to-one function, on-to function, many-to-one function, into function, and bijective function. Under based on degree, we have identity function, constant function, modulus function, greatest integer function, sigma function, polynomial function, rational function. Let us understand each of these function one by one. Function is said to be one-to-one function if each and every element of domain has only one distinct image in range. One-to-one function is also called as injective function. To understand one-to-one function, let's solve few example. In first example, there is two sets, set A and set B. In set A, we have element 1, 2, 3, 4. In set B, we have 5, 6, 7, 8. 1 is related to 5, 2 is related to 6, 3 is related to 7, and 4 is related to 8. As per the definition, every element of domain has one and only and distinct image in range. So this is one-to-one function. Second example, consider set A and set B. Set A contain 1, 2, 3, 4, 5 and set B contain elements 6, 7, 8, 9. 1 is related to 6, 2 is related to 7, 3 is related to 8 and 4 is related to 9. But 5 does not have any distinct image in range. So this is not one-to-one function. Last example, consider set A and set B. Set A contain 1, 2, 3 and set B contain 4, 5, 6, 7. Every element in set A has unique and distinct image in set B. So this is one-to-one function. Onto function. A function is said to be onto function if every element in its codomain has at least one corresponding element in its domain. Let's solve three examples to understand this statement. In all example, set A represent domain and set B represent codomain. As per the statement, every element in set B must have connection with set A. Then it is said to be onto function. First example satisfies that condition, so it is an onto function. Second example, 6 does not have connection with A, so it is not an onto function. And last example, both the element have connection with A, so it's an onto function. Many one function. A function is said to be many one if two different elements in the domain have same image in the codomain. Let's solve some example to understand this. Set A represent domain and set B represent codomain. Element 1 and 2 has same image. So this is many to one function. In case of second example, no two elements have same image. So this is not many one function. In last example, two element has same image, that is 6, but 2 is also connected with 8. So this is not many to one function. Into function. A function is said to be into if at least one element in codomain does not have any connection with elements of domain. In below example, set A represent domain and set B represent codomain, and 7 does not have any connection with domain. So this is into function. Last type of function under based on mapping is bijective function. A function is said to be bijective if function satisfies the condition of 1, 1 and onto. Let's see below example. Set A represent domain and set B represent codomain. As we all know, every element in domain must have connection with codomain. Then it is said to be 1, 1. And every element in codomain must have connection with domain. Then it is said to be onto. This example is satisfying both conditions. So this is bijective function. Now let us see some more function under based on degree. First one is identity function. Function is said to be identity if f of x equals y, where x equals to y. To understand this, let us consider two-dimensional coordinate system and plot x equals to y curve, which is passing through the origin. Any point on the curve, x will be equals to y. As you can see right side, when x equals to minus 2, y will be also equals to minus 2. And x equals to 2, y will be also equals to 2. Which means the mapped element must be always equal in identity function. Then it is said to be identity function. Constant function. A function is said to be constant if value of y is independent of x and always same for any value of x. One of the best example for constant function is f of x equals to 3. When x is equals to 1, f of 1 will be equals 3. When x is equals to 2, f of 2 will be equals 3. Similarly, when x is equals to minus 1, f of minus 1 will be equals 3. The value of y will be always constant for any value of x. This type of function is called constant function. Modulus function. A function is said to be modulus if it satisfies condition f of x equals x when x is greater than 0, f of x equals minus x when x is less than 0. In this two-dimensional coordinate system, I have applied this condition. So we are getting this graph. When x is equals to 1, then y will be also equals 1. When x is equals to 2, y will be also equals 2. When x is equals to minus 1, y will be equals minus of minus 1, which gives 1. Similarly, when x is equals to minus 2, f of minus 2 will be equals minus of minus 2, which is equals to 2. So by this, we can tell that modulus function always remove negativity of value. Another important note about modulus function, domain belongs to real number, range always lies in between 0 to positive infinity. Greatest integer function. A function always give lower integer value for decimal value and same integer value for integer value is called greatest integer function. When x is equals to 0, greatest integer function will be giving 0. When x is equals to 0.9, greatest integer function will be giving 0 itself. When x is equals to 1, greatest integer function give 1. Now let us see for negative values. When x is equals to minus 0.2, greatest integer function will give minus 1. I hope you got this. If we apply this logic in two-dimensional coordinate system, we will be getting like this. This look like step. So greatest integer function is also called as step function. Domain of greatest integer function belongs to real number. Range of greatest integer function will be always belongs to integer. Signum function. A function is said to be signum function if it satisfies this condition. F of x equals 1 if x is greater than 0. F of x equals 0 if x is equal 0. F of x equals minus 1 if x is less than 0. When x equals to 0, output will be also equals to 0. When x equals to 0.1, output will be 1. Similarly, for 0.2 also output will be 1 and so on. When x is equals to minus 0.1, output will be equals minus 1. When x equals to minus 0.7, output will be equals minus 1. So on. For all negative value, output will be minus 1. We will be getting graph like this. Such type of function is called signum function. Domain always belongs to real number. Range either can be 1, 0, minus 1. Polynomial function. Function is said to be polynomial if it contain variable, coefficient and involve only operations like addition, subtraction and multiplication. You can say in the example, x represent variable, 2 and 3 represent coefficient and plus represent addition operation. Two important note, power of the variable must be always positive integer. And second important note is graph, domain, range varies with expression. This type of function is called polynomial function. Another last function is a rational function. Function is said to be rational if it contain h of x and g of x, where h of x and g of x is polynomial function and g of x is not equals to 0 or any constant value. Such type of function is called as a rational function. Now we have covered all type of functions and relation. In next video, we are going to understand few important topic related to objectives. Thank you for watching. Please subscribe, like, share. Click on bell icon for further update.